Let's start off with like a very brief introduction to alignments and the three different elements that go into an alignment.
Okay.
Toe, camber, and caster.
Exactly that. Let's keep it real simple here. Your basic first angle of alignments would probably be camber, the most talked about angle of all. It's basically the tilt of the wheels, where the top of the wheels would tilt inboard towards the motor would be a negative camber situation. Straight vertical would be zero camber, and tops tilted out would be a positive camber situation. Most cars run negative camber, if not all cars run negative camber, and it's just the amount of camber you would put in a car. Leading into caster angles. Caster angles are angle that most people just don't realize what it does for the car. In a nutshell, it's not a tire wearing angle. It's a handling and a feel of the car type of angle. It is the relationship of, let's say, a car with upper and lower ball joints. It'd be where the lower ball joint led forward the upper ball joint.
So could you give us like an example with your hands?
Sure. Like all alignments are calculated at the wheel as a reference point, but really what you're reading is the suspension. And let's keep it simple on a car that has upper and lower A-arm. A strut unit works the same way. It's still a pivot point from upper to lower, but let's just use a ball joint to ball joint to make it easy. Let's say you are...
So the wheel is here.
The wheel's here, and I'm on the passenger side, let's say. And this would be a negative camber situation where ball joint to ball joint, so the tilt of the wheel would be like your hand is, tilting inward, zero camber or positive camber. Again, all cars come with negative camber. Caster angles, the most unknown part of the alignment angles. It's the same ball joint positions, but it's actually the leading of the lower ball joint would make it a positive caster, or vertical would be zero caster, and then negative caster. All cars come with positive caster. Caster is the one angle that would create a pulling. It would create stability. And in certain circumstances, like a car like a Subaru, you put any lift kits on, and it would create maybe a 1 degree gain in caster, which is a little bit of stability, but also creating dynamic camber. So as the wheels being like this with the ball joints, as it turns, it lays down the wheels forward, goes more vertical, and then lays down the wheels again under the other direction. Under zero caster, it would be like a butterfly valve where it just turns in its own axis, gaining no camber or losing no camber.
So essentially, when you have additional caster and you're turning, you can get more lateral grip.
Correct. That would be a really good benefit of dynamic camber coming into it, and but that's plays a very small part in the overall alignment. It is a part of it, but it's not the key part for that type of turn-in. The last angle would be toe-in. Toe-in would be like being exact parallel would be zero toe. Being slightly pigeon-toed would be toe-in or toe-out. Most stock cars, rear-wheel drive cars, will always come with a slight toe-in. A slight toe-in would be anywhere from, let's say, 1/16th to an 1/8 inch toe. Creates a lot of stability. It also creates a little bit of, lack of better words, a little bit of laziness. And I'm going to use the other word, hyper, under toe-out situations. The car gets quick and agile and very hyper. Great for racetracks, great for canyon driving, where you want the car to turn in and stop understeering. It's a great way to create that type of situation.
Okay, so we were talking earlier, and you said you have kind of 4 types of customers. Tell us a little bit about those and how, let's say we've got the novice, the guy who's bought his first sports car, he's going to the track for the first time, he doesn't know a lot about alignments,
Yes.
At least performance alignments, and he's looking to you for some guidance, so he pulls in and tell us about the 4 guys, and then starting with this guy, how does the dialogue go between all of you?
Okay, the average customer comes in here with this new hot rod toy, as you will, and every manufacturer on the market will set a car to understeer. Understeer meaning as you apply your turn-in to turn, the car actually has a delay and actually pushes forward like it's understeering. From there, we go from understeer to neutral to oversteer. What I would try to create for that newbie would be a car that would be neutral, maybe even dabbling with slight understeer. And people are like, why would you do that? It's a very safe way to put a car on the track. As a car understeers, it may push and plow a little bit, but it's very predictable and confident inspiring that you know that you can probably just let off the gas, get rotation, and get on with your turn. Unlike oversteer, the rear end will come around, and unless you're maybe an advanced driver or something of go-kart backgrounds where we're very used to having a rear rotation, it could get away from you, and that's probably one of the bigger reasons why people hit walls: the loss of a rear suspension, traction, and then out of control through the dirt onto a wall, and no more fun from there.
So let's say someone just purchased their new Subaru off the showroom floor. They're now considering they've owned it for a couple of weeks. There's no reason that the tires are out of alignment according to Subaru specs.
Correct.
Why might they want to consider getting an alignment before they go to the track, and how do you set that car up?
Okay, let's target Subarus. Being an all-wheel drive car, like I said, all manufacturers set up cars to understeer. And it's a great way to stay out of court for these manufacturers. People like myself tend to try to untune that understeer and make it more neutral. So the first thing I'm going to probably do is get slightly more negative camber in the front for the average street guy. Let's just call it 1 degree. They come stock about 0.3 or 0.4. Let's get into about 1 degree, something that won't hurt tires too much, run zero toe on their front, and all of a sudden, wow, triple the spec, double the fun for sure, without costing too much tire life. 1 degree is about a safe number to use. As we start getting into the 1.5s and 2s, which are more of a light race spec, maybe a canyon run spec, it's more of a preferred spec for the advanced drivers, going all the way into your race car stuff, which would be maybe 3.5 degrees or better.
So the tolerances that manufacturers allow for new cars is a lot greater than they would be for, someone like yourself who's setting someone up to go on the track. You're not going to accept like 0.5 degree camber on one side and,
Correct. Exactly. Good point there. There are factory tolerances. Most of your computer alignment machines, they all use factory manuals, factory books for their specs. If you ever saw a factory spec book for a Subaru, it would be something, don't quote me on this, but it'd be something similar to 0.3 negative on the front, give or take 0.3 negative. So that means either 0 is good or 0.6 is good. In my world, that's terrible. I'd like to set cars to the exact spec, whether it be 0.75 exactly on both sides, 1 degree on both sides. It's always going to be a symmetrical alignment angles so we could get symmetrical feel left to right turns.
So when you set up the car equally on both sides, what is someone going to notice? Even if they're just a newbie, when they drive off and you send them around the block, what are some of the reactions that people get when they go from the factory alignment to a little bit more of a sportier alignment, but that where the specs are exactly the same on both sides?
A very common reaction would be the big smile. The big smile pretty much says all. Anytime you could get a car to be just on spec, and especially when we get to pick the spec and actually tailor the spec to that driver's needs, they tend to be almost overwhelmed by the performance of their car, that they already had the car, and all I did was kind of tune the car for their needs, and that creates a big smile on most people's faces.
Okay, now let's take that newbie. He's gone to a couple track days. Who does he become? Who's that second person that you tend to see a lot coming in to get alignments?
It's a very common, I use 4 layman terms here: street, aggressive street, light race, full race. It would be that next level of the aggressive street guy. It's the guy who says, I'm not mom and dad, mature mom and dad, not the idiot either, but it's the guy who says, I like to go to the track, dabble with the track, but more than anything, I like to go up to the canyons and just kind of have some fun with my toy. That would be the next level, the streetable, performance-minded car, and there's a whole lot of them. That's probably 90% of my business.
So the difference between the first and second guy is that you send the first guy out who may not have a lot of experience at all.
Yes.
He starts to develop some impressions. He comes back. He's done a couple of track days now, and he maybe wants to do lowering springs or something. He's getting into the sport a little more, and he says to you, here's what I like, here's what I dislike. I mean, how does that exchange go? Is it just like that? What are the things that you...
It's about like that. My very first visit, as a tuner, I want to make it first and foremost, as a tuner, I don't give you exact science. I will give you a great baseline. If anybody told you different, they're probably blowing sunshine up your way. As a tuner, I take all the information given to me that I actually interview you before I line your car, and then I take all the information and try to tailor those needs into alignment specs. I have certain categories of the Ford I told you about, and those four can also be broke down into subcategories. But from my background and from the overall masses that come through here, you find yourself from, let's say, the newbie guy that I would set it slightly understeerish, maybe neutral, to get a car that's for sure neutral and maybe slightly going towards oversteer, meaning the rear end is a little bit more lively and tends to rotate slightly under turning conditions, which lessens your turn angles to the front. Again, I'd be conservative on that on a novice driver, but give him a little bit of that taste, and he would come back from the track again and say, man, that was a great change. I'm a lot happier. That person will also outgrow those specs and get into the advanced driving. Those are people who tend to like a lot of tire rear rotation. Rotation meaning the rear end coming around, not quite like a drift car, but nice clean four-wheel drift, as you will. And it's the fastest way to go around a track is to get the car to drift. And those tend to be where the front camber exceeds the rear camber now, the front toe out in the car now, the rear going to zero toes, and the car seems a little bit more lively and more quick and agile and willing and wanting to turn.
Okay, and now as this driver evolves and he becomes the light race and full race setup, he's going to go from maybe lowering springs to coilovers.
Yes.
Now, what are the advantages to going to coilovers and
Huge benefits for coilovers. Simple product, been around a long time, just offered to the average layman for the last 15, 20 years. It's the greatest thing. Coilovers offer quite a few things. One is most coilovers use industry standard springs. They're not the manufacturer size springs like a 4 to 6 inch wind diameter. They're going to be industry standard. Very common is 2.5 inch ID, 2.25 IDs. They come in different lengths, 6 inch, 8 inch, 10 inch, and they come in different spring rates. 50-pound increments on generally speaking. You can pick and choose your spring rates. If you buy a lowering spring from, let's say, a well-known company like Eibach or H&R, you don't know what the spring rate is. They're not going to give you that spring rate. It's just a lowering spring. It's designed to lower a car, give you a certain look. In the coilover world, we are going to pick and choose our spring rates. If I feel like we need a 550-pound spring in the front, I want a 550-pound spring. I don't want it 502, and I don't want it 480. I want 550s, and I get to pick and choose my spring rate. Coilovers also offer the greatest benefit is corner weighting. The biggest question asked to me all the time is, I just got coilovers, but I'm not a racer. Should I align and corner balance my car? And the first thing out of my mouth is not just because I'm professional and it's my trade, but of course you should corner weight your car. This is the technology you bought. The reason why coilovers were invented was for corner weighting. It was not invented for ride height control. It's a side benefit.
for those that don't know, why would you want to corner balance your car?
The word corner balancing, most people don't know that term. They hear the term, they don't know what it is. Corner balancing is putting a car on 4 scales, hooked up to a computer, and it actually weighing each corner at the same time and giving you weight percentages and exact weight measurements. Through coilovers, I'm able to transfer weight from corner to corner until I can achieve the mathematical formula of weight times percentage, which is at the very end result, cross weights 50-50.
Okay, and let's say someone is still in that aggressive street. They've gone to the track a couple times. They've got their lowering springs. And let's say even like the company that sold them the lowering springs will give them like, here's the spring rate.
Yes.
And they like it. They go out. You've maxed the camber out. They're at the point where they really need the maximum camber. They put in the camber plates.
Yes.
What are the signs that you see that suggest that they need to go to they need something stiffer?
It's really about tires themselves. Tire reading is pretty much a telltale sign of what your suspension is doing. It's the end result of, and that's really what it comes down to. We put all these components on so our tires could have stiction. As you look at certain cars, you'll notice that maybe their outside edges are completely bald, but they've already ran 3 degrees camber. It's probably not the camber, and you're not going to keep adjusting camber for 4 degrees because now you're not going to have any straight line traction. probably at that point your spring rate's a little soft and the car's rolling over on its side, creating outside tire wear.
So the outside of the tire is actually wearing a lot faster than the inside of the tire.
Because the car's rolling over in a corner, and you can't help that. So either you're going to do one of two things. You're going to put heavier spring rates in, or you're going to put any sway bars on there, and they do overlap. They work hand in hand together. So if you undersprung, maybe you can over sway bar a car, and it's a quick fix.
And so let's say for the person who's looking to add stiffness, if they say, well, if I'm going to evolve from the novice guy to the light race guy, or even to the full race guy, why don't I just start there? What's the disadvantage to going above and beyond what you're either used to or you're trying to jump that to that next level?
Right. Like we talked about, as you evolve into from, let's say, the newbie beginner to the novice to the intermediate to the advanced driver, the setup is a lot different as far as the feel of the car. If you put a beginner into a advanced person's car, they probably wouldn't like it for the reason of that the car is so loose feeling. It takes all your confidence away. So that's what I'm telling my newbie drivers, to just work your way towards novice, get a sensation of a loose car, get that under your belt, and then just go to a looser car, because as the car gets looser, meaning rear rotation mostly. And rear rotation is the greatest thing in a race car. You have to have it, but it takes away all confidence. Anytime your rear end's trying to outrace the front, it's hard to be confident in a corner. But as you are confident with that setup, there's nothing going to be faster than that car.
Now, if you are the novice guy and you're looking, okay, I've got a little bit of money saved up, and beyond tires, what is like a really good bang for the buck product in your opinion?
I've always said one of the biggest bangs for the buck is probably sway bars, especially adjustable sway bars, meaning they have option holes. Unlike OE sway bars, they have one option hole where your drop link goes down to the frame and you're done. It's the size of the diameter of that bar is really what you purchased. In aftermarket world, they usually give you at least 2 to 3 option holes, sometimes 4 option holes, and these are leverage points on this bar, which would take it from the edge of the bar, the softest position, which would be, say, equal to stock. Move it in 1/4 inch to the next hole, it's maybe 10-15% stiffer, and you do the math along the ways, and you could actually increase stiffness of the sway bar, which is almost like adding spring rate to a car.
Well, how does a sway bar work exactly, for those that don't know?
Okay, the real name for a sway bar would be anti-sway bar. That would be the real name for that. And what it does is a sway bar is like a U shape on average, generally speaking a U shape, and it's connected at the very tips of the U's to drop links that are connected to the control arms, generally speaking. And as a car sits level and flat on ground, it's just neutral. That's exactly where it should be.
So there's no pressure
there's no
up or down
preload on the sway bar whatsoever. There should be none, and that's the key to a sway bar, especially race car sway bars. When we have adjustable drop links, that's why they make adjustable drop links, so we can actually shorten and lengthen sway bar links to neutralize those sway bars. And by having that, it's one of the biggest bangs for the buck, because now you just have adjustability in the car, which actually overlaps spring rate. And the beauty of a sway bar is in straight line driving, it doesn't really change overall feel of the car, meaning going over bumps and this or that. It's activated by when the car wants to high side, and as the car high sides, it actually bends the bar high side, and the bar stiff enough that says, no, you're not going to bend me that far, so it puts it back down, which flattens the car back down to flat to level again, and that's when a sway bar is working in your favor. And again, as we go into sway bars, I often use bigger is not better, proper is better, and remember that proper is better, not bigger is better.
And what does that mean, proper as opposed to bigger? What are you getting from a proper sway bar?
Okay, let's go back to the Subis on the early versions of WRXs. In the States, these are new cars for us as tuners. We've seen them for the last, let's call it 8-10 years, let's say. Australia's been playing with these cars for 25 years. I got to say, Australia probably has a little bit more hold on what the car is doing, dynamic forms, this and that. When the WRX first came in, everyone complained, understeer. Yes, we know. And there was a sway bar out on the market, and it was to downsize the front sway bar, to make the front not so stiff so it would have calculated time to bite and then have traction and then turn in. As a tuner, I believe in that. Okay, they over sway bar the front from the factory. Let's go to a smaller diameter bar and get the car to bite. No one bought into it. As us Americans, bigger is better. So what we do, we put bigger sway bars in the back. it's a quick fix, but really the fix was the proper sway bar in the front. And it's kind of like overspringing a car. You just don't go bigger is better. You find the right balance of the car, and that should be the key place where to start.